Welcome back, students. In this video, we are going to look at hydrohalogenation, but of an alkyne this time instead of an alkene. Let's remind ourselves what happened first with hydrohalogenation of an alkene. We've seen this reaction before where you started with an alkene, you added HBr, and the bromine went to the more substituted side. Remember, when your nucleophile adds to the more substituted side, we call that the Markovnikov product. What about hydrohalogenation of an alkyne? Well, if you only have one equivalent of the HBr, you're still going to end up with an alkene at the end because the reduction is only going to happen once. So let's count our carbons here because it's really easy to lose them as we go from an alkyne that's linear to something that's sp2 hybridized or sp3 hybridized that we draw as a zigzag. So we want to make sure that we have all 4 carbons. So I've got my 4 carbons. I'm still going to have an alkene here because the reaction is only happening once. And the bromine is again going to go to the more substituted side. So I put my bromine on the more substituted side. What if we had plenty of bromine? That's what this excess means. Remember, this means excess, like you have as much as you could possibly need. We'll go ahead and we'll draw out our 4 carbons again. And when we do this, now we have 2 bromines adding, and they're both going to add to the more substituted side. So you get a dibromo product. What if we wanted this to add to the less substituted side? What would we do in that case? And that's what we're going to look at next. If we desire the anti-Markovnikov product, like how we did with alkenes, we have to add peroxide. Your favorite peroxide is H2O2, but don't be surprised if you see somebody just write a general peroxide either in this format or in this format. When we have a peroxide, that forces the reaction to put the bromine at the less substituted side. So let's again draw out our 4 carbons, and now our bromine is going to go to the less substituted side. If we only had one equivalent, that means only one of the pi bonds reacts, so we still have that one pi bond. Now, in this case, you can actually get both stereoisomers. You can get the trans product and you can get the cis product. Well, in my opinion, I wouldn't run this reaction because I don't like separating products at the end. It is not fun. You probably haven't experienced column chromatography yet, but it takes all the patience in the world, and it is long and it is tedious. So I'm just going to change my reaction. I'm going to go ahead and say I have all of the HBr in the world that I could possibly want, which is 2 equivalents, and both of the bromines are going to add to the less substituted side. This way I have one product at the end and I have less to clean up when I'm done in lab. This way I have one product at the end, so I don't have to separate any mixtures when I'm in lab. Let's wrap up. In this video, we looked at hydrohalogenation. In hydrohalogenation, a hydrogen and a halogen add across the pi bond. Naturally, the halogen will add to the more substituted side, and if you only have one equivalent of HX that you're utilizing, you're only going to get one addition so that you have an alkene and a halogen at the end. If you add plenty or 2 equivalents, then you can have 2 additions happen where both of your bromines or both of your halogens will add to the more substituted side. Unless you use peroxide, which will force anti-Markovnikov addition. Thanks so much for your attention. This is Katoni signing out.